Today we're going to work on finding the missing side length of a similar figure. Let's first talk about the word similar. We have here a picture of a gumball machine. We might want to enlarge the size. So let's say I double it in height. I also have to double it in width to make it larger. So then it would still be similar. It looks the same. I could also shrink it down. Maybe I'm going to make it 1/3 the height and 1/3 the width. I'm going to have it be smaller. I'm doing the same thing to the height and to the width. I could also just rotate it on its side. It's still similar. So the height to width ratio is still the same. But over here, these ones are not similar. For this one here, it looks like it got a little bit smaller in the width, but it stayed the same height. Maybe it got a little bit taller. That's silly. We can't do different things to the width and to the height. And this next one here, this one looks like it got shorter, but the width didn't change. That's not fair. So these ones are not similar to the original. So again, a similar figure, we'd have to change the width and the height in the same way by multiplying by the same number or using what's called a scale factor. So let's give it a try. All right, so my first shape has two side measurements of 6 and 15. So I'm going to write a ratio of those two numbers. I like to write the ratio using the smaller number on top or the shorter length. Then I'm going to write a ratio using my other sides. And again, I'm going to put the smallest one or the shortest one on top. So 12 over x. Then it's just like our last assignment. So I'm going to look at the smallest number first, and I'm going to see if it can multiply by anything to make 15 or 12. Ooh, I know that if I could multiply it by 2, I would get 12. So I'm going to do the same thing down here. So this 2 is our scale factor. So I'm going to double the height, so I also have to double the width. 15 times 2 is 30. So that is the length of a missing measurement. I doubled the height. I doubled the width. Let's try another. All right, so I'm going to write the ratio of one shape, and it doesn't really matter if you start with the larger shape or the smaller shape. But when you write your ratio, I do like to write, the smaller measurement on top just to kind of keep some consistency so that I don't accidentally write one the opposite way. So the shorter side over the longer side equals the shorter side over the longer side. Okay, I like to choose my smallest number and see if that can go into one of the other numbers. So I notice that 3 can go into 9. What should I multiply it by to make 9? Ooh, 3. 3 times 3 is 9. So I'm going to do the same thing down here. Some number times 3 is 18. 6. So my missing number is 6. I'm going to switch colors for a second. I could have also noticed that 9, that didn't change colors, whatever, could be multiplied by 2 to get to 18. So I could also multiply by 2 over here, and 3 times 2 would also give us that 6. So we have some options. All right, let's try another. All right, I'm going to write my ratio of these two numbers. I'm going to do the smaller or shorter one first, and the longer one second, the shorter to the longer. Then I'm going to say, hey, I know that if I multiply 5 by 2, I get 10. So I'm also going to multiply by 2 down here. What number times 2 is 14? It's 7.